In this session, we will have a brief introduction of several other speech enhancement techniques like microphone array speech enhancement and speech deliberation. After the use of adaptive filtering, the main microphone can remove one part of the noise from the reference microphone. When adding one more microphone, another part of the noise associated with the main microphone will also be removed. ANC will animate the noise-related part of the two microphones. In the speech enhancement method of the microphone array, because more microphones are used and the spatial information of the signal is considered, it has more advantages than single-channel speech enhancement in terms of suppressing interference in specific direction and performing speech separation. Microphone array speech enhancement methods are currently widely used in smart speakers, robots, and other fields. Taking advantage of the multiple microphones, this type of products can achieve speech enhancement in the far field and more complex acoustic environments. A microphone array has any number of microphones operating in tandem. Multiple microphones set up in certain formation depend on the applications. The forms of microphone array can be line, circle, rectangle, and so on. Each microphone captures the sound from the source at different time due to the distance from the source. Therefore, there is a time delay in each signal. The microphone array speech enhancement technology retains the speech signal in the desired direction and suppresses the signal in the undesired direction. In fact, it realizes spatial filtering with beamforming, which is a means of transmitting or receiving sound preferentially in some directions over others. The general form of the beamforming output is based on delay and sum. The main microphone array methods include fixed beamforming method, adaptive beamforming method, and post-filtering techniques. The applications of fixed beamforming are very limited, but the computational complexity is low, so it is generally used in an environment where the acoustic scene is fixed, while the adaptive beamforming method shows better robustness. Of course, this is also at the expense of computational complexity. The current adaptive beamforming methods mainly have two structures: linearly constrained minimum variance, LCMV, and generalized side lobe consoler, GSC. Today's microphone array speech enhancement algorithms are basically improved and optimized based on these two structures. The traditional beamforming method will leave some noise, and the ability to suppress some noise is not strong. So, the post-filtering technique is used to combine the single-channel noise reduction method with the microphone array method. The fixed beamforming algorithm is the earliest and the most classical. It draws on the idea of antenna array signal processing and uses a simple delay-sum method to achieve noise suppression. This system has better robustness and less computational complexity. But in practical applications, it needs more microphone to achieve better directivity and higher signal-to-noise ratio. The delay sum method can be divided into 3 parts: time delay estimation, time delay, compensation, and the summation part. There are many weighting methods for the summation part. The simplest is average weighting. The main idea of adaptive beamforming is to use the output of the signal to adjust the weight coefficients adaptively, so as to achieve a certain robustness to change in the acoustic environment. The figure shows a kind of GSE method in time domain. The delay sum signal, that is noisy speech, subtracts the analog noise signal output by the block matrix operation to obtain the estimated target speech signal under the minimum mean square error criterion. Under open environmental conditions, if the number of noise sources is less than the number of microphones, the adaptive beamforming method can achieve good performance. In a closed environment, reflection and reverberation will produce multiple interference conditions, and the noise cancellation performance of the adaptive beam method will be relatively limited. It is difficult to obtain an ideal speech enhancement effect using the delay sum method. The microphone array speech enhancement method, based on post-filtering techniques, eliminates irrelevant noise by adding post-filtering after the traditional delay sum output. One possible structure of microphone array speech enhancement using adaptive post-filter is shown in the figure. After delay sum operation, the noise containing speech signal is filtered by Wiener to obtain the estimated target speech under the minimum mean square error criterion. This method can achieve better noise cancellation performance with a relative small number of microphones in an environment of uncorrelated noise. Reverberation has a negative effect on speech intelligibility and reduces the recognition rate of automatic speech recognizers. Far-talk microphones, where the distance between the speaker and the microphone is large, are significantly corrupted by background noise and room reverberation. Far-talk speech is an important task for the ASR and other speech processing systems. Reverberation is produced by multipath propagation of an acoustic signal from its source to the microphone in enclosed spaces, and it distorts speech signal along both time and frequency. The distortion of reverberation to an acoustic signal can be modeled by the acoustic impulse response, AIR, which may last for hundreds of milliseconds. A reverberant speech signal, YT, at time t, can be expressed as the convolution of ST and HD plus the background noise. HD corresponds to the room impulse response, RIR, between the speaker and the microphone. ST is the clean speech signal. Convolutive reverberation can be expressed in terms of RIR with the form in time domain. Reverberation cancellation has been tried by many researchers using deconvolution techniques that estimate and apply the inverse of the AIR to the reverberation microphone output. Although it has been studied for decades, speech dereverberation remains a challenging problem from both a theoretical and practical perspective, particularly when reverberation is combined with background noise. Microphone array beamforming is one of the most established multi-channel speech enhancement methods. It combines the received signals such that sound waves from a desired direction are preserved, whereas reverberation and noise coming from other directions are suppressed. That's all for this chapter. See you next chapter.